Hello everyone, again it's Lwandile here, the leader and the instructor of Manikwe School. Today we're actually gonna be getting our hands dirty with exercise 4.7. As you guys can see on the screen, I've already created a project called exercise 4.7, and I've went ahead and created a class from student A's perspective, shortly put, right? Okay, so let me read through the question. Again, it seems like it's gonna be one of those problems that requires me to give out some visual situation of what's happening, right? Even though they don't want us to do that on the program, but for the sake of everyone to better for the sake of everyone to better understand what's going on, right? It's better if I also give out some visual solution, okay? Anyways, let me read through the question itself, okay? So suppose a pentagon is centered at 0, 0, which is the origin, with 1 point at the 0 o'clock position as shown in figure 4.7c. Write a program that prompts the user to enter the radius of the bounding circle of a pentagon and displays the coordinates of the 5 corner points on the pentagon. So here is a sample run. Here's figure 4.7. I hope everyone can see. So without any waste of time, let's jump onto our code. So I've already let me see the sample run. I've already took care of this part over here, which is nothing else but to prompt the user to enter the radius, right? Okay, so now let's get to the core of this exercise here. So the very first thing I want to do without doing anything will be to validate my radius. So I'll simply go radius. If radius is less than or equals to 0, I'll simply go system.out.print make sure the radius is a positive number. Done, right? Immediately I do that, I'll simply exit my program. Again, you can get away with simply using if else statement instead of this line over here. We've done selections, so I hope everyone understands that, okay? So now that I've done validating my radius, the next thing I'll simply do will be, again, remember folks, I'm doing this from student A's perspective, so there's gonna be some stupid way of doing things. There's gonna be some stupid way of doing things, of course, yeah. Okay. Even though our solution is gonna work, but you guys know that student A is the dumbest, in fact. Okay, so here's what I'll do. I'll simply create a constant, and I'll call that constant angle, right? Or perhaps clock angle. Let me just go angle. Basically this angle here, let me just go first point angle. That makes more sense. Okay, Okay, so I'll simply make that 45. Oh, not 45. So basically that's gonna be our angle for the point P1, right? Okay, once I do that, perhaps I should comment it out. The angle for the point P1, done. Now what I want to do, I'll simply go double. Now on the x coordinates of that, P1 x coordinates, that is simply given by radius multiplied by it's r cos theta, basically, where theta is our angle. So it's gonna be r cos first point angle, of course. Okay, that's gonna be it for our. So now I want the value for my. If you did polar coordinates in mathematics, then you would understand where is this formula coming from, and if you didn't, I'll simply explain that in a moment. Right now I want to get over first point angle. I want to type this thing. Okay, so in case you're confused, luckily they gave this here for us. This is how you get your x coordinates. It's r multiplied by cos alpha, and you'll get your y coordinates by r multiplied by sine alpha, as you can see here in figure 4.7b. Okay, now we're done with our first point. The next thing to do will be to get the o'clock point, right? That we can simply do by doing this. Again, I'm trying to avoid wasting time here. I'll simply put 2 there and then 90 met dot pi all over 2. Same thing applies for my y coordinates. Again, I'm hoping people are still with me here. I simply copied and pasted this for the sake of avoiding wasting time, right? Okay, here's what I'll do. What I'll simply do is to have a string that will hold these coordinates. Okay, and I'll simply do that by going string point 1 is given by open brackets point. Let me do this. Copy, paste, concatenate that with the comma, concatenate that with, then put y here, and then lastly you put your closing bracket. Done. I hope people are clear what's going on here. Again, basically what I'm trying to do is to have a string that will hold my coordinates in a good format still. So it's gonna be open brackets x is to y brackets y. In fact, this is how I'm supposed to write this. Oh, maybe a comma will do it. Seems like a comma will do it. Okay, that should be it for my first point. Again, I'm putting this backslash n here so that whenever maybe this string is displayed 0.1, whenever 0.1 is displayed, whatever that's going to be displayed is going to go to the next line. This is simply backslash n simply works more or less like your print len statement, right? Again, here this will be my point 2. Okay. Okay, basically what I do is, again, it's better if I copy and paste so that I'll avoid wasting time. I don't know though, maybe I'm confusing you guys. Okay, so now we're dealing with our dead point, and our dead point, since we know that P1 has an angle of 45 degrees, right? And we know that the y coordinates for the two is the same. What we've got to do is to use logic here. Okay, what we'll simply do, we'll just go for our third angle. Let me print this first and then just go 0.3, 0.3. Okay, go. Okay, as I was saying, 0.3 will simply be 180 minus 45. I hope everyone is clear there why we're saying 180 minus 45, right? We're doing that in order to get 0.3, right? Because if you start from here where my cursor is and go all the way, if P2 is our 45 degrees, then right underneath our P3, where our y coordinates is 0, our angle is actually 180 degrees, right? So in order to find our angle for P3, we'll simply say 180 minus the angle for our first triangle, which was 45 degrees. So again, how am I gonna go about doing that? I will simply go math.pi. Math.pi refers to the angle 180. So I will simply go 180 minus my first point angle. Likewise for y, I'll do that. Again, I hope everyone understands where is this coming from, right? I hope everyone understands, right? Okay. I know I'm used to naming my constant using capital letters, but I'm not gonna change it now just because I'm not gonna change it now, right? I know I'm used to that, but for the sake of avoiding wasting time, I'll simply leave it like this. Okay, so now we're dealing with 0.3 and we're gonna make this our 0.3. We need a string to hold 0.3 coordinates. Now let's go back to 0.4. So what we'll simply do for 0.4 is to go 180 plus our first angle. I hope everyone understands again where does that come from. Because if we if we had a line, a horizontal line here which corresponds to our x-axis, then you would notice that the distance from your x-axis to point P3 is exactly the same as the one from your x-axis to point P4. So that implies that we can get the point P4 simply by going 180 plus our first angle, how did I name that? Okay, I just said first point angle, so it's gonna be our first point angle, 180 plus our first point angle. That's gonna be it for our fourth point. Again, I'm doing this from student B's perspective, from student A's perspective, so I hope people will understand. We'll simply replace the minus with the plus here. Again, I've mentioned this, you guys. It seems like we're gonna need a visual solution on this. I'm gonna try by all means to give one for you guys. That way you'd get to be assured of what's going on, right? You'll trust my solution. Anyways, okay, we're done with 0.5. My very last one will be 0.6. Again, I can simply go for 0.5. I can simply go. I can simply find the 0.5 coordinate angle. By going minus 45. Since we know that our first angle is 45 degrees, which is pi over 4, we can simply negate that and then get our last angle. Again, it's a matter of doing whatever you're comfortable with. That's one way of doing it. Another way will simply be 360 minus our first angle, right? And 360 minus our first angle is equivalent to just going minus our first angle. This corresponds to 0.5. Okay. Now let's see what we got. Let me just display the 3 points. The 5 points. That will be the only thing that is left for me to do right now, and that is to just go system.out.print. Again, I could have been more stupid by going point, or just go output and simply say output is nothing else but 0.1 plus 0.2, concatenate that with 0.3 and 0.4, and lastly 0.5, and then simply go output over here. However, I'm not gonna do that. I'm not gonna do it like that, because you guys can see we don't necessarily need that variable. So that's why I'm gonna display everything. I'm gonna put everything on my system.out.print method. Okay. Basically here the trick was in being able to find these coordinates. Once you do that, you simply put those coordinates on your on your string, right? Again, you could have avoided having your string variables. However, it would have been tedious if we do so. Can you imagine having something like this for each and every one of these variables, you see. So that's why I decided to just have variables for those, right? So let me hit the run button and see what do I get. Remember, folks, we're doing this from student A's perspective. Why is this thing so slow now? It was good a few seconds ago. Why is it messing with me now? Okay, as I was saying, let me just put 100. Oops. That was so stupid of me. Forgot to round off my answer. Okay, you might think that I'm wrong. You see, these solutions aren't, they aren't the same, right? Number one, why? I'll tell you that in a moment. Okay, the reason is simply because you see this angle here. This angle here, the angle 4.1 isn't 45 degrees, right? This angle here, 4.1, is not 45 degrees. However, on my solution, I decided to use degrees. So that's why I said I'll also give you guys a visual situation of what's going on. That way you'll believe me. You'll believe that I'm giving you guys a working solution. The problem with this program here is only that we decided not to round off our answer. And if you've been following my tutorial, you'll understand that we do round off our answer whenever we want to. So I'm going to do that on my next solution. But again, I'm not messing with you guys. The reason why we've got different numbers here, it's because the angle of point P1 in this case here in figure 4.7c isn't 45 degrees. Basically, what we can do is, okay, I'm not gonna do that. You'll see it on the next solution. That should be it, you guys. Cheers, I'm gone for now.